Hi everyone. The last time I talked to you, I may have been a little bit confusing by the way I described things, especially about the periodic table. So I want to take a couple minutes to clear things up just a little bit. Now, first, I'm going to try to put on the screen a periodic table. Okay? Hope that looks just about right. Starting off, well, on the periodic table, the way it works is this. This side right here is what you call the alkali metals, right here. Then you have the, see, yeah, then you have the alkaline earth metals. Then you move over this way and you get the transition metals. And then as you get over here, this is where you get the Nobel gases and you get some metalloids right here. Now I'm going to try to put it up so that you can actually see it better. Okay. Now, again, it gets a little tricky because I'm looking at it reverse. So right here are I'm going to try to put it up so it looks all right. Right here is I'm trying to figure out how to, okay, alkali earth metals are here, I think. And then, oh, no. Yeah, no. The alkali metals are here. Alkali earth metals are here. And then these are transition metals right here. And then you get over toward the Nobel gases right here and the metalloids in this area. Okay? Hope I got that completely understandable. Again, I'm looking at what you're looking at. It's backwards for me. Transition metals are in the middle. Now, the groups here have similar properties. These are groups. These have similar properties, okay? The rows, these right here, these rows are where you're going to find, this is the number of energy levels are on each atom. The energy level of, you got nucleus, and then you have a energy level, and then you have a, let's see if I can show you, nucleus right here, and then you have an energy level, and an energy level, and an energy level. Now, down here, as you see in these groups, not only have similar properties, but they have the same number of valence electrons. Okay? Similar properties and same number of valence electrons. So, you got alkaline metals, alkaline earth metals, transition metals, and then you get noble gases, metalloids over here. Now, something you should know. Metals are normally transmit electricity easily. They conduct electricity easily. They're normally shiny. You can usually hammer them out pretty good, and you can make wire out of them as well. Whereas the non-metals don't conduct electricity so well. They're more brittle and they're not as shiny. The metalloids are in between. Okay, so now let me give you another thing about the periodic table. It's important. Each box is a representation of an element. Each box. Now, in this case, this is going to be helium, number one. This is hydrogen. Excuse me. Helium's number two. Excuse me. Hydrogen's number one right here. Hydrogen's number one. The one and the two and the three, four, five all the way across. That number one, that number at the top is the atomic number. The atomic number is the number at the top. That's the number of protons that you have in that nucleus of that atom. And if it's got that many protons, most likely it will have the same number of electrons in the energy levels. Another point about the energy levels. The first energy level that surrounds the nucleus is going to have no more than two electrons. Second level, no more than 8. And it stays at 8. It keeps on going up. Now, as far as the way these squares work, you got, I'll go back to here. Excuse me, I don't mean to confuse you. Hydrogen's right there, okay? That's got an atomic number of 1. Number 1 is going to be right above that. And H is going to be right there. Then there's going to be another number right down here. It's going to be called the mass number, atomic mass. That number is going to be the number of protons and the number of neutrons. Okay? So once again, top number is the atomic number, which is the number of protons. Then you have the element symbol, in this case an H. And then down below, atomic number, which is going to be number of protons and number of neutrons. Are we on the same page? I hope so. Now, there is a question which a student asked me about, and I got it wrong. I'm not going to mention the student's name, but they'll figure it out once I tell them what it is. It had to do with the element thorium, which is actually down here somewhere. It's number 90. Now, I attempted to tell that person, go ahead and draw a bunch of energy levels around it. And they were like, well, how do I get to 90? Good question. That's because I gave them the wrong answer anyway. They didn't want energy levels. They wanted a box like this, which had the number at the top, which would have been 90, and the mass number, which would have been right below there, and the T or TH that represents thorium. That's what they were looking for. My bad. Then you have, let me make sure I get this right here. You look at the groups as being properties are similar and energy level is the same. Same group, same energy level, or same valence electrons. Excuse me, same number of valence electrons. Now, regarding valence electrons, the valence electrons are the electrons on the outside shell. The electrons on the outside shell are valence electrons, and they are the ones that do the reaction, the main reaction with the other elements, okay, the valence electrons. Now, with that in mind, I'm going to switch real quick to physical and chemical change. I'm not going to be much longer. Physical change simply involves two atoms come together, or two molecules come together, but no change happens. Real change. No change in the properties. In other words, if I have a glass of milk here and I got chocolate in here and I drop the chocolate in here in the milk, all I'm going to do is make chocolate milk. I'll still taste the chocolate and I'll still taste the milk. If I put a piece of wood in that water, I'm going to put wood in the water. The wood's still going to be wood and the water's still going to be water. There's no change. A mixture and those combinations I told you about, that's physical. There's no change to the actual substance. So when you have chemical change, there's actual change to the substance. If I take a cup of this and I have a cup of purple powder and I put it into white powder and I put them together, I'm just making these up, just go along with me. You put them together and they fizz and they melt and they spark, whatever, that's chemical. If you start a car and it goes that's chemical because the gasoline is combusting. That's a chemical change. If I torch a piece of wood, that's a chemical change because I'm creating wood, creating the gas and also the charred, maybe carbon that's on the outside edges because of the flames. As far as physical properties are concerned, a physical change only makes something wet or mixes it up. There's no actual change to the substance. Now, real quick, like when you have a chemical equation, let me give you an example of a chemical equation right here. It's a real simple one. C plus O2 equals CO2. All right? C plus O2 equals CO2. Look what it says here. You got C plus O2 equals CO2. That's a chemical equation, right? And that means you have C, carbon plus oxygen coming together to be carbon dioxide. It's also a balanced equation because the total number of atoms here is going to be equal to the total number of atoms there. That's called a balanced equation. One other thing to talk about. It's called endothermic compared to exothermic. Endothermic and exothermic. Endothermic is all about heat. Endothermic is all about heat added to a process to make the reaction take place. Exothermic is about heat being released. Endothermic, exothermic. Endothermic, exothermic. Endothermic heat is applied to make the chemical reaction happen. Exothermic heat is released. I think that sums it all up. If not, you can send me a message. I hope that makes sense. And I'm sorry it took me so long to do it. I wanted to make sure you got it. You say, we've already done this. Yeah, but let me tell you a little thing real quick before I hang up. And that is this. When you were talking about chemistry, and I know you don't like to memorize. I know you're like, no, memorize. But the more you study that periodic table, the atomic number, the mass number, the symbols, the equations, the more you study that, the more you're going to get it. And you really need to try to get it. Do you get it? Ha. Anyway, talk to you later. Bye.